So this is the version 6 of PatientLevelPrediction Shiny Viewer. So this Shiny Viewer had a few updates from previous Shiny Viewers. It's now actually using the Odyssey Shiny modules package to actually get the Shiny code, and it should make it a lot easier for us to be able to update the Shiny apps. So when you first run the Shiny app, you get this about page. Just gives you an information about the general Shiny app viewer. But to view the prediction results, you want to go over to this left-hand menu where you can select prediction. Once you've done that, if you press these arrows at the top, these lines at the top, you can actually get rid of that side menu and it will expand the page a little bit. So I recommend doing that because some of these tables can be quite long. So the more space you have for the tables, the better. So when you first go to the prediction tab, what you'll see is that you have a table that tells you all the model designs that you have run, and it gives you summary information about how many different model developments, how many validations, how many diagnostics studies have been done with this design, some estimates about the performance. So each row corresponds to a model design ID. Then you get information about the type of model. So for this, I fit 2 logistic regression models with the lasso regularization. It tells you information about your target population. If you have used cohort definition sets when you've run the multiple PLP, this would actually get populated with the real name. If you've never given the name, so the PLP never knows what the cohorts are, it will just take the ID, the cohort definition ID. So it will say cohort and then the cohort definition ID. So here I haven't actually given a name. I just said it's the ID 4, so what cohort 4. And then for the outcome, again, I didn't give it a name, so it just says 3, cohort 3. But if you run this with the information for the cohorts, this would actually be populated with the actual names. Then you have your information about your time at risk. So when you're predicting the outcome occurring relative to the target population index. So here we were doing a 1 to 30 day prediction and a 1 to 365 day prediction. The nice thing is if you see something at the top but you don't understand what it means, so if you say what is tar, if you hover over it, you're actually getting a pop-up now that will actually tell you what it means. So here you get information about what each of these columns correspond to. So if we move over, the next section, once you've kind of got the prediction task summary, is the min, the mean, and the max AUC for any of the internal or external validations that have been done with this design. So because we only ran one, you'll see it's actually, these are all the same, but here it just tells you what this actually means. And then the next 3 columns tell you how many databases this model design has been diagnosed on to see if the design is suitable, how many databases this model has been used to fit a model for model development, and how many databases have been used to do validation. So because we haven't actually done any external validation, we haven't used any non-Eunomia data set. These are all just one database, which is Eunomia. So then you end up with 3 buttons. So for each row, there's 3 buttons that you can select. The view diagnostics, if you click that, a new modal will pop up and you'll get information about the database that you evaluated. Again, you have the cohort and the outcome names, and then you have numbers and you get some information about whether you've passed or failed or it's unknown. If you want to click what it is, if you click on and hover over 1.1, it tells you this is the participants were appropriate data source used, e.g. cohort, randomized control, clinical trial, or nested case control study design. Because PLP uses a cohort design, this automatically passes. And you can look at the next one and it tells you, well, all inclusion and exclusion of participants appropriate. And here we've got a pass. So there's set rules that we have at the moment to check these. And it looks at the model design, it looks at the data, and it looks to see if there are any issues with these different criteria. And these are PROBAS criteria. So for now, the diagnostics are linked to the PROBAS criteria. So you see here it says, are all predictors available at the time the model is intended to be used? It's saying unknown. This is because there's no guarantee that the variables that are recorded before index will be there. If, for example, if your database actually has some lag in recording the target population index, perhaps actually some of the variables that were recorded before may have actually occurred after. So that's why we've put unknown here. And that really, to answer this, you need to understand your data and see if there's any potential issues that could arise because of your data set and potential issues in the data set. Then 4.1 is whether there was a reasonable number of outcomes. This will be if you have at least, I believe it's 1,000 outcomes, this is going to pass. If you have less than 100 outcomes, this is going to fail. And if you have between 100 and 1,000, then it's unknown. You may have enough depending on how easy the prediction task is, but you also may not have enough. So this is something that you just need to do some further investigation. And then the diagnostics, you also have a few plots. So you can view participants. And what this does is in the population settings, and you can actually specify these different washout periods, first exposure, prior outcome, look back. And I kind of mentioned when I was talking about the running the multiple PLP that you can do in the run single PLP, you can do a sensitivity analysis for these. Well, what this table is showing you is the value you set, which is 180, and it summarizes the number of people who are in your target population who had 180 days look back, the outcome percent for the people who satisfied the 180 days look back, the min age, the basically age distribution, and the gender and well the sex distribution at 180 days if you have a 180-day washout look back. And then it also does that if you had no restrictions. So if we didn't have the 180-day washout period, what would that be? Now, because everyone in our cohort had at least, I think, a 1-year look back, this actually isn't any different. But if your cohort didn't have a washout period, but your population settings did, this would tell you if your inclusion criteria has shifted your age or sex distribution. And it might be showing you that maybe the target population has been biased in some way. So the idea of this is to look at some general statistics about the population that you've got included in your data versus what would happen if you didn't have the inclusion criteria for the different inclusion criterias. And then you can go to predictor. And what this does is this actually gives you a survival plot for your population settings and tenure. So you can actually, this is because we did a 30-year time at risk, this has actually got a survival plot for the 30 days. And this is just useful to look at to see, are you picking a reasonable time at risk? So if you saw that everything dropped down initially on day 5, initially it starts at day 5, but if at day 5 everything kind of dropped down and you see that most of the outcomes are occurring straight after index, one, that may be signaling that you've got some sort of issue, that maybe your time at risk is too close to the index, and maybe you're actually not really predicting but more diagnosing illnesses. So that kind of may highlight an issue. Or if you kind of like go flat here and then you shoot down, then maybe and it can continues to decrease past. So if you, in theory, the 10-year I don't think is working on this because we don't have 10-year follow-up for the data set we have. But if you were to look at the 10-year, you could see whether there's a decrease. So lots of people are having the outcome past the end of your time at risk, and that may make you want to expand your time at risk. So this is really to explore, one, do you potentially have issues with your timing of your outcome in that you may not be doing true prediction? And two, did you want to expand your time at risk maybe to actually capture more time because you're seeing that's actually where the outcomes are occurring? And then the outcome, this is telling you the percentages of the cohort with the outcome versus the value. So you're looking at here, we're looking at age, so the age distribution for the whole population versus the whole cohort versus the final population based on your inclusion criteria. Because this data that we tested on, there isn't, like, we didn't really filter anyone with our inclusion criteria. We're seeing it's the same. But if you saw, for example, there was differences, then again, this could indicate that your inclusion criteria has caused a bit of a bias. And also, this also gives you some overall information about how often, like, what's the most common age in your data, and is this what you'd expect? So here you can just see, is the target population and the inclusion criteria fitting what I know about is target population phenotype and population settings fitting the intended target population? So are we seeing age and gender and year and month distributions that we would expect? So if you knew the outcome was becoming more common, then you'd hopefully see that there's an increasing trend if you knew the outcome should be stable and if you see a stable terrain. So this can just make you see just a further inspections really on top of the cohort diagnostics to see if your target and your outcome populations are being well defined. So once you've checked that and you're happy with there's no major issues to design, we didn't see any negative crosses, so that's all good. You can press dismiss and then you can actually go to view results. So if you go to view results, what will happen is you'll see any models that were fit here. So here we've got the development database, the validation database, the target population, the outcome, the time at risk, and now we have a bit more expansion on the performance. So here we're seeing the AU RFC, which is pretty poor. We're seeing the error into precision recall curve, how many people were used in the target population, how many outcomes there were, what percentage were used to do internal validation. So here we used basically 1/4 of RT and 1/4 of our outcomes to do internal validation. And then you have information about how common the outcome was, when the model was fit, and whether it was development or validation. So if we had done validation in a different database, another row would have popped up here saying validation with the same statistics. You can actually explore the validation results. Now, if we click this result, you'll get information about the database name. Because we used the eunomia, we just put the schema is just the name basically ends up being was put as main. But this would actually pop up with the actual database name if you were using real data. Then you can look at your settings, like your population settings that you chose. You could have a look at any pre-processing that you picked. So here you can actually look at all the different settings, and you can look at the cross-validation, for example, performance. You can look at the attrition. So you can see here the settings. So this is all your model design settings. Then if you want to go to your model, you can actually click here and you'll get the covariates that were actually selected by the model. This model did poorly because you can see here it's not really picked anything that's different from the diagonal. So there isn't really anything that was discriminative picked. Here it tells you how many non-zero covariates were in the model, tells you your intercept if it's logistic regression, and then you have information about the variables that were selected in the model, how often it occurred in people with the outcome, without the outcome, and the standardized mean difference. You can see which things seem to differ the most. Threshold dependency, so this is just telling you your things like your sensitivity, specificity, positive predictive value at different thresholds. You can move the threshold with this bar here. So this was in the previous Shiny viewers. This hasn't really changed, and then you have your dashboard here of just the overall performance. If you change this threshold, this gets changed. So if you were trying to apply this model, you could actually pick a threshold that you think would be give you a good sensitivity and specificity for how you'd want to use it. Then discrimination and calibration. The difference really in the latest PLP is that now this is a table, and you'll see that each of the different evaluation types here can be picked. And if you want to plot them, you just have to press this view button. So if I want to see what the test performance plots are, I click test. On the test row, I click view, and now it will pop up with all of the plots. So we get our distribution plots, and we get our standard rock plot and precision recall plot. And these are interactive, so if you hover over, you can actually see the values. But if I want to see the cross validation instead, I can click that, and now I've got the cross validation. And you see this is a bit smoother because the cross validation had more data. Because we only had 2,000 people, cross validation is probably a bit better than the test set, because the test set is going to be quite small and have a lot of variation. And we've got similar sort of thing now for the calibration. Again, you have the rows, you have more information about the calibration. So you've got all the calibration summary information here. And then you can also select one of those. You can select the test. It will plot the test. You have the smooth calibration. You have the demographic calibration. And if you go to click here, we get the cross-validation ones as well. So the main difference is really that we now have these buttons, and you can actually select the type. And the good thing is as well, if you've done any subgroup analysis in your results, then this will actually pop up and actually have different subgroups, and you'll be able to select them here. Net benefit was added in the old PLP. It may have been after the last video, because the last videos are quite outdated. But this now just has a plot for net benefit, and you can pick whether it's test, train, or cross validation here, and then these tables and the plots will update. Validation has information about the model that you fit plus any validation. So in the example for the run multiple PLP, I actually validated this in the cohort 2, And now you actually see there's an extra row here where you can see actually how well your model did when it was validated on a different database. So everything, not different database, with a different target cohort. So same database, same settings, but just different target population. And if we want to compare the two, we can select both rows, and then I'm not quite sure why this has happened. This should normally have a plot, but my guess is the data is probably so small here that it's got some error. And then the calibration here, so you can have the ROC and the calibration plots to compare them. So if we get rid of this, you should, for example, there should have been 2 of these plots when you select these. And if you have lots of different validations, you'll have multiple rows, and then you can select them. We will be at some point making an update to this where you'll be able to actually give it a name, rather than it right now it just takes the T, the O, and the database and puts them together. In the future, we'll actually have it where you can manually name these, so that if you want to, you can call the line whatever you want. And that's then you can press this button to go back to the model summaries. And if you want, you could, if there's multiple models, you could select a different model. And if you go back here, it will take you back to the original page that you're on. This is the starting page. This is all the model designs. So if we wanted to now, we could select this result and we could repeat the process. So this is when we're doing a 1-year prediction. So we should have more outcomes. Our outcome instance is much higher.